This is Geometry, Chapter 1, Section 5, in which we will discuss angle relationships. There are a lot of different relationships between angles and among angles, and some of those we're going to look at today. When you have two angles that lie in the same plane and have a common side and have a common vertex, such as this picture, they're together, they have a side in common, and they have the same vertex. We call those adjacent angles. Angles that do not fit this, that are not adjacent angles, are surprisingly called non-adjacent angles. So angles 1 and 2 here are adjacent. Angle 3 and angle 4 are not adjacent, non-adjacent angles. They have the same vertex, but they don't share a side in common. Angle 3 and this big angle would be adjacent. Angle 4 and this other angle over here would be adjacent. But 3 and 4 are non-adjacent. If you have two adjacent angles and the non-common sides form a straight line, we call that a linear pair. And here's a picture of that. Angle 1 and angle 2 together make a linear pair. They have a common side, and their other sides make a straight line. If you have a pair of intersecting lines, then you get vertical angles. Vertical angles are the ones that are not adjacent to each other here. So 1 and 4 are not adjacent, they're vertical. 2 and 3 are vertical. 1 and 2 are adjacent, they're not vertical. They have to be across the vertex from each other to be vertical. Notice here vertical does not mean up and down. 2 and 3 are vertical angles even though they're horizontal, if you will. It's not that meaning of vertical. Couple of other ones. If we have angles that add up to make 90, you've probably seen this term before, we call those complementary angles. And if they add up to 180, we call them supplementary angles. We're going to use those two words a lot. Two very special relationships to be aware of. If ever you have vertical angles, they are congruent. Two vertical angles are congruent to each other. And if angles are in a linear pair, they are supplementary. So let's find a couple of things out here. We're looking for the measures of two angles that are supplementary, and the difference in their measures is 18. If we have two supplementary angles, that means they add up to 180. So x plus y equals 180. And it tells me their difference is 18, so x minus y equals 18. Well, this is set up perfectly for elimination. We have x plus x, that makes 2x. The y's cancel out, equals 198, so dividing by 2, x is 99. We've got one of the two angles, now we need to find the other. So we'll plug 99 into either equation. I picked the top one, but it doesn't matter. 99 plus y equals 180, so subtract and we get 81. So the two angles are 99 degrees and 81 degrees. So I'm going to ask you to pause here break out your old algebra skills and your new terms that you know, and see if you can solve this problem, and then come back and check your result. So we're looking for two complementary angles. The larger one is 12 more than twice the smaller one. Complementary, x plus y equals 90. The larger angle, I picked x to be the large angle, is equal to 12 more than twice the small. This one is set up just begging for substitution, so I substituted this stuff in for x. 2y plus 12 plus y equals 90. Collect terms, subtract and divide, and we get what y is. That's the smaller angle. Now we could plug the y into here, or we can plug it into this. I plugged it into the top and subtracted. Found out that my two angles are 64 and 26. If we have two things, lines, segments, and or rays, any combination of those that intersect at right angles, there's a special term for that. Perpendicular. And there's a symbol for perpendicular. Looks like this. It's an upside down T, is what it amounts to. So our job is to find values that for x and y that make these two lines perpendicular to each other. Well, what does it mean to be perpendicular? It means equals 90. So I need to make this angle down here equal to 90. So 2x plus 5x plus 6 equals 90. Collecting terms, subtract over the 6, and divide, and we get x equals 12. We're halfway there. Now on this other one, also equals 90. So 4y minus 2 equals 90. Add the 2 and then divide. Y is 23. Now the last things we need to talk about in this episode, this video, are things you can assume from a picture and things you cannot assume from a picture. Because we look at diagrams frequently in geometry, and we need to know whether we can trust our lying eyes or not. So there are some things you're able to assume by looking at the picture. For example, you can assume if they look like they're in the same plane, they are. You can assume, if I spell together correctly, that lines that look, or points that look like they're on the same line are on the same line. If there's a line between them, then you can assume they're actually on that line. If it looks like the lines intersect, it appears on the picture that they're crossing each other, then you can assume they do. You can assume that the points are in the order they're shown. They're not going to try to trick you and have B in the middle between A and C, but then when you work it out, you find out that B is way over here to the right. You can assume they're in the right order. You can, in fact, assume that if it looks like it's interior to an angle, it is. If it looks exterior to an angle, it is. If it looks like two angles are adjacent to each other, if it looks on the picture like they have the same side, and they're right next to each other, they really are. They're not slid just a little bit apart to try to trick you. And if it looks like they make a straight line, you can assume they in fact do make a straight line. They're not going to try to trick you with that. Those are things you can assume. Things you cannot assume. You can't assume just because they look like they're perpendicular that they are. You know they cross each other, these lines. You know lines cross each other, but unless you're told they're perpendicular, you can't just assume they are. And we'll be adding to this list later, by the way. You can't assume just because they look equal that they are. You can't just look at segments and say, oh, well, those two look to be the same size, so they must be. No. Could just be laziness of drawing. Could be that you didn't know, so you just drew it however it looked, however you needed to. Same thing with angles. You can't just assume that angles are congruent because they look like they are. Unless you're told they are, you can't go with that. And this is the one that always gets people. You can't assume relative sizes. Okay. Suppose I have that, and I have some segment here that cuts that off. And I do some work and I find out that this is 8, and from the algebra this is 2. And we did a problem, we worked it out, and this is what we came up with. This smaller piece over here was 8 and this bigger piece was 2. And people look and say, well, that can't be right because this one's way bigger. No, it's not. 8 is bigger than 2, I know it is. What in effect happened is when we drew our picture, we drew it in the wrong place. But we didn't know that at the time. They just told us that this segment was going to be, 2x minus 1, and this segment was going to be x plus 4 or something. And we worked out the problem. Just because one thing looks bigger than the other doesn't mean you can assume it is. Okay. So hopefully, as always, if you had questions along the way, you jotted those down. Bring those in with you, and we'll see you in class.